Well, hello again. It's been a little while since I've done one of these. I apologize. Life just gets busy. All right, so Dev Diary 3 on GroundwaterViz. So if you don't know, what this is a little project of mine where I'm loading in groundwater model data from MODFLOW 6. I convert that to 3D geometry, and the idea is to just visualize the data. And to build that, we're using the Qt framework, C++17, OpenGL is our graphics library, and CMake and GCC is our build system and compiler. All right, so what I was kind of occupied with the past month or so since posting last was working on reading in actual MODFLOW files. Um, they come in like a bunch of files if you're not familiar with MODFLOW, but the first file we're trying to read is the dis file format, and all that is discretization and just like we're trying to read in like a cube model here. So you can think of this as like the number of rows, right? Right, 1, 2, 3, 4, 5 in this little figure. And then a groundwater model would have layers. So this is kind of representing different rock types or earth types in the profile of the earth as you go with depth. And then there's also the columns. And the idea is like this is kind of the base of the rest of what we do here is actually building the grid within our viewer, because once we have the grid, then we can start coloring cells to match like kind of boundary conditions, things like, oh, if there's a river there, what does that look like in the cell, and then assigning properties or reading the properties, like if this is sand versus clay. So far, we started with the simplest of the file formats, which is dis, which is just rectangular cells. And it gets a bit more complicated after that. This is kind of the next step here, is to do disv and disu. Disu is pretty like a one step up, where you kind of have instead of perfect grid cells of equal size, you can have like kind of finer discretization within them. So we kind of have like a coarser grid here, and then over here we have like more and more detail, and then here's another example where we have even more refinement kind of below. And then there's also there's disv, which is just taking in vertex data. This is where we can get into more complicated things like Voronoi meshes, and what this is just triangles oriented in space, and each point has a coordinate system. So then you're actually reading the cells instead of reading like the number of layers and rows. Okay. So the disk file format kind of is made of 3 chunks. The first is the options block, which I actually haven't done yet. Then the dimensions block, and then grid data. So options block, which again typically optional. You can kind of input things like length, export file formats, the origin of the model. So if you're in like a coordinate system like UTM, whatever, this would be showing MODFLOW or showing the reader where you are in space. Then we have dimensions, so that's the number of dimensions, so the number of layers, number of rows, number of columns, and then finally we get into the grid data. So this is where we get into the spacing of our grid. So there's del R, which is the spacing in the row direction, which is maybe a little bit of a confusing term, but the idea is like as you go along the row, how far apart are those grid cells spaced? As you can see, they're not the exact same size. So similarly, we have del C, which is the spacing along the column direction, and then we also have the top of the model, so that's kind of called top, and that's sort of the uppermost elevation. Then after that, we have like an array of n col by n row by n lay, so that's kind of like for each grid cell, it'll have a bottom, right? And then finally, we have I domain. So this is where we get into the inactive active cells. So sometimes when you're groundwater modeling, you kind of just want to like restrict flow or communication between grid cells, and the easiest way to do that is just to set it to be inactive. And this is an example of the output. So like I was saying, the begin options block, you can have length unit meters, right? So length units, and then you tell the model it's meters. Then we have number of layers, number of rows, number of columns, and then we get into the grid data. So our reader would have the ability to read in keywords like internal. So when it's internal, that just means that all the data that you need is inside of the file itself, versus external, which reads an external file. There's things like factor, which is like, okay, apply a factor of 1 to each of these cells as you go along, and then that's kind of like a way to kind of shorten the file. So if it's like your spacing is 10,000 kilometers or whatever, you could just do 1, 1, 1 and then have a factor of 10,000. Then there's constant, right? Because oftentimes these are perfectly square grid cells that will never really change. So you can use constant, and then alternatively we have things like layered. So each layer will have its own value. In this case, it happens to be constant. So the next steps is maybe doing an options block. I don't know if it's actually worth it to do it right now, but another very, very important thing is for me to actually do the dis-v and dis-u readers. And then once I have that, I think I have enough of a skeleton to my project here to start reading in like things with color. So that would be the IC file. This is where we have our initial conditions, things like the initial saturation of the model, or you know, the boundary condition or the hydraulic conductivity. And then also importantly, once you run the model, MODFLOW 6 model, you want to read the output files, like what's predicted by the model, right? That's kind of important. So there's a bunch of output control files like the head file or CBC, and then there's also there's budget files, things like that. And then after that, you know, once we're doing more of that scalar rendering, that's where we're going to look at hydraulic conductivity, color maps, and then things like that. Of course, slicing of the model, that's kind of maybe a later stage thing, but right now we're just plotting things in 3D without like the ability to cut inside the model and see what's going on. And then another thing is to actually make a UI, because a lot of this unfortunately is hard-coded right now because I'm kind of just digging through the IO section of this. So I'll just quickly hop through the project here. So all that happened different was IO. I have a dis readers, right? So the idea is I have an object that can read MODFLOW files, raw MODFLOW files, and then kind of like what I was saying, there's like a parse dimensions, parse grid data, and a few things were pretty challenging with this project with learning fstream and stood string stream. So I'm learning all about the standard library more and more. Yep, input string stream. Yeah. Alright, I'll show you what I got, or maybe I'll start here. Okay, so just as an example, I made a little file, test constant dis, 6 layers, 6 rows, 6 columns, or sorry, 5 rows, 6 columns. The x and y are constant, but then the top kind of is varying a bit. The layering is also varying. It's constant, but you know, each layer has its own kind of thing. And then finally, the I domain has an inactive layer, so 0. And I'll just kind of show you what that looks like. All right, so as we kind of talked about, the top of the model has different elevations. That's what's going on here. For the moment, I kind of just set it so that it only renders the external face, which is why it kind of looks a little funky. But you could see that it's still working pretty well. Like the layers that are red are active, and then that one layer in the middle is blue, which is exactly what I want to just kind of show the active versus inactive portion. So yeah, anyway, thanks for checking out the project. Hope you enjoy these videos. If you do, check them out. And yeah, till next time.